We are now going to construct the ionic equation for the reaction that I've written over here, where ammonium sulfate, which is an ammonium salt, reacts with a base, in this case sodium hydroxide, and produces sodium sulfate, water, and NH3. Now the first thing is, this is not a balanced equation, so I would try to balance this equation. So there would be 2 NaOH, 2 water molecules, and 2 ammonia molecules to balance this equation. So I have a balanced equation now in front of me. And the first step now is to learn about the states of all these compounds, whether they are soluble. If they are soluble, they are aqueous, and if they are insoluble, they would be in solid state. So the first one is ammonium sulfate. It has the ammonium ion in it. So I'm going to refer to the solubility table. So here's the solubility table, and if you look at the table, the second statement, all group 1, NH4 plus 1, NO3 minus 1 compounds, they are all soluble. Any compound that contains group 1 in it, NH4 plus 1 in it, is going to be soluble. So this first compound is an ammonium compound, so it's going to be soluble. It's going to be written in aqueous state. Similarly, the second compound, NaOH, is also soluble because Na is in group 1, and all group 1 compounds are going to be soluble. This compound over here is also a group 1 compound. Na is in group 1, so this is also soluble. And you're left with water and ammonia. Water is in liquid state and ammonia is a gas. So only these 3 compounds are in aqueous state. Any acid, base, or salt, if it's in aqueous state, it's going to dissociate into its ions. So the next step now is to write these ions in dissociated form, the ones that I'm going to try, that I'm underlining. This ammonium sulfate over here, this NaOH, and Na2SO4. All of these should be written in dissociated form. So ammonium sulfate would be written, it has 2 ions. Remember to identify those ions. There's an ammonium ion in it, and there's a sulfate SO4 2 minus ion in it, and they would dissociate, they would scatter in water. So they are dissociated, and they are 2 ammonium ions because initially all these ions were joined together, but when you dissolve them in aqueous state, they dissociate. So I write this big 2 instead of this small subscript 2, because that indicates that there are still 2 ammonium ions, but they are now scattered, they are not joined together. Similarly, NaOH would be written in scattered form, in dissociated form. It has 2 ions, sodium ions and hydroxide ions, so there would be 2 sodium ions, Na plus, and 2 hydroxide ions, since you had 2 NaOH compounds, so they are in aqueous dissociated form. And when we move to the products, Na2SO4 is again, it has 2 ions, sodium ions and sulfate ions, and there are 2 sodium ions. The small 2 indicates that they are joined together, but when they scatter or when they dissociate, I would write this big 2 because now they're not joined together. And there's 1 SO4 2 minus ion in it, so that would also be in aqueous state. And I have 2 more products. One is 2H2O in liquid state, and 2 NH3 ammonia in gaseous state. So these 2 products, these 2 compounds, one is liquid and the other one is a gas. Only the acids, bases and salts, if they are aqueous, they're going to dissociate into their ions. So this is dissociated, this is dissociated, and this is dissociated. Moving to the last step now, I need to find out which ones are spectator ions. Spectator ions are the ones that are not doing anything, they're not taking part in the reaction, they remain unchanged. So let's start with this ammonium ion. This ammonium ion is taking part in the reaction because in the product side, there is no ammonium ion. It changed into NH3, which means that it did something in the reaction. Then you have these SO4 2 minus aqueous ions, and my product side, I still have SO4 2 minus aqueous ions, which means that they did absolutely nothing in the reaction, and they are spectator ions. They were watching the reaction happen and they were not taking part in the reaction. So get rid of these sulfate ions, don't write them in the equation. The next ion is sodium ions, 2 sodium ions aqueous in my reactants, and in my products I still have 2 sodium ions in aqueous state, again, which indicates that they did not do anything in the reaction. So I'm going to get rid of them. I will not write them in the reaction. So I'm going to cut out in the product side as well. Then I'm left with these hydroxide ions, OH minus 1 ions, and they did take part in the reaction because on the other side there are no hydroxide ions. They actually changed into something else. There's water, So they probably changed into water by accepting H plus 1. So these ions, they did take part in the reaction. So I'm going to rewrite the equation, but without the spectator ions. So it's going to be 2NH4 plus 1 aqueous plus 2OH minus 1, and that's also aqueous. And in my products, I'm going to have 2 water molecules in liquid state and 2 ammonia molecules, and it's 3 molecules in gaseous state. So this is going to be my ionic equation. I just got rid of the spectator ions, and the leftover equation is the ionic equation for this reaction.